let's continue our discussion on factoring and bring in another topic or another type of factoring, which is factor by grouping and factoring larger degree polynomials. Let's begin by factor by grouping. If we're to give a cubic as x to the third plus 20x squared minus 5x minus 100, and I ask you to factor that, well, with what we know so far, we could not factor that. We have a cubic, but we don't have the difference or the sum of perfect cubes. But what we can do is we can group this, and maybe we can group these two together and group these two together. And really our grouping is going to be arbitrary. However, a good rule of thumb is that if we have 4 terms, we're going to look for 2 of them and then 2 of them. So we're going to pull 2 of them together and these 2 together. And we're going to look and concentrate on these first 2. We're going to look for a GCF. If I look at x to the third plus 20x squared, our GCF is x squared. And we're going to be left with x plus 20. Remember, if I were to distribute this back in, I would end up with x to the third plus 20x squared. If I look at these 2 terms, my GCF is negative 5. Remember, if our first term is negative, we always want to pull out that negative as well into our GCF. Pulling a negative 5 out of these 2, we have x plus 20 as well. Notice our 2 quantities are the same. So what we can do is we can essentially factor those out as well. So our greatest common factor between these 2 terms, remember we separate terms with a plus or minus sign, so here's our first term, here's our second term. The 2 factors that are in common are x plus 20. We're going to be left with, if I divide this term by x plus 20, I'm left with x squared, and this side, I'm left with a minus 5. We can't factor x squared minus 5, so this is our completed factorization. Notice we grouped up here in order to be able to factor completely down here. Let's go ahead and take another example, and let's look at x to the third minus 2x squared plus 3x minus 6. Again, this isn't factorable by any method except for by grouping. So I'm going to group the first 2 together, and I'm going to group the last 2 together. Pulling out my GCF, I have x squared. I'm going to be left with x minus 2. In these 2 terms, I can pull out a 3. I'm going to be left with x minus 2 as well. Now I have 2 terms that I've created, my first term and my second term. Within these 2 terms, I have x minus 2 in common. So I can pull out an x minus 2, and I'm left with x squared from the first term and a plus 3 from the second term. And there's my completed factorization. X squared plus 3, remember, doesn't factor any farther from there. If we look at example 3, let me move it up there a little bit for you so you can see it. Oh. Right. Here, let's take one last one with factor by grouping, x to the fourth plus x minus 1. Notice here, if I group the first 2 together, I can pull out an x to the fourth, and I'm left with x minus 1. But in the second 2, in the last 2 terms there, I don't have a GCF. So essentially what we can do is pull out a 1. So we're left with x minus 1. Here we have x to the fourth plus 1 are the 2 outside terms, and our GCF was x minus 1. Unfortunately, x to the fourth plus 1 doesn't factor, so we say it's done. Now let's go ahead and look at a couple of factoring where we have a larger degree polynomial. And this can be quite interesting and quite fun and honestly quite long. So we'll keep it small. X to the 16th minus y to the 16th. If I look at this one, we should see that we have the difference of perfect squares. X to the 16th is a perfect square, and y to the 16th is a perfect square. So we're going to factor this. Well, if I think way back when I did x squared minus y squared first. Remember, we took this and we factored it. We took x minus y and x plus y. We took the exponents and took the square root of them. Well, we're going to do the same thing here. Remember though, when we take the square root, we're actually dividing that exponent by 2. So we get x to the 8th minus y to the 8th and x to the 8th plus y to the 8th. Notice when I multiply these together, remember we add exponents, so 8 plus 8 gives me the 16, y to the 8th and y to the 8th gives me y to the 16th, and my two middle terms are going to cancel each other out. Here we have a positive x to the 8th and y to the 8th, and here we have a negative x to the 8th, y to the 8th. But look, x to the 8th minus y to the 8th, that's factorable. As long as these two exponents are even, and they're the same there, we have the difference of perfect squares. Even if they're not the same, as long as they're even, we have perfect squares. So we can factor x to the 8th minus y to the 8th. And that's x to the 4th minus y to the 4th. And x to the 4th plus y to the 4th. And we're going to bring down our x to the 8th plus y to the 8th. Remembering that the perfect sum of squares is not factorable. If we look at x to the 4th minus y to the 4th, that factors for us x squared minus y squared and x squared plus y squared. And we're going to tack on these other two, x to the 4th plus y to the 4th and y to the 8th plus, or x to the 8th plus y to the 8th. But if you look, x squared minus y squared, we just talked about it up here, we can factor that to x minus y, x plus y, and then bring down our other three terms, x squared plus y squared, x to the 4th plus y to the 4th, and x to the 8th plus y to the 8th. And there's our completed factored form of x to the 16th minus y to the 16th. What I'd like to do is show just a couple more examples, and these are examples that are going to allow us to factor some other strange things. Here's our example 5. Let's take, for example, x times x plus 1 quantity squared minus x squared times x plus 1. This is kind of going back to our factor by grouping. But we already grouped them at one point, and now we can look at each of these terms. Notice we have one term here and one term here that we're separating by that minus sign. So if I look at this, I have a quantity that's the same, x plus 1 is the same, and I also have an x in common. So I can pull out the common factor of x and x plus 1. What I'm going to be left with, well, if I take an x and factor out an x, that's gone. If I take x plus 1 squared and factor out an x plus 1, what we're doing is subtracting the exponents. I'm going to be left with an x plus 1 to the first. Inside, or minus, from the second term, I have x squared, or I had x squared. I'm factoring out an x, so I'm going to be left with an x, and my x plus 1 is going to factor out. Now I can go inside these brackets and clean this up. So I have x times the quantity x plus 1, and then inside here, x plus 1 minus x simply gives me 1. So my final answer is x times x plus 1. Now I'm sure you're all asking the same question. Isn't that just what my GCF was? Well, will it always work out that way? Of course not. Let's look at an example where that doesn't happen, which would be example 6. Here, let's take x minus 2 times x plus 1 to the third, and subtract off it x minus 2 to the second times x plus 1 to the second. So here we have two terms again. Here's our first term, here's our second term. Remember, we separate terms with a plus or a minus sign, and these terms are all multiplied together. These are multiplied together. So if I look, I have x minus 2 in common, and I have x plus 1 squared in common. If I factor out an x minus 2 times x plus 1 squared out of my first term, I'm left with x plus 1 Again, we can subtract the exponents. Here it was a 1. I have 1 out here, so they're going to cancel. 3 minus 2 gives me 1. And here minus, we're going to take x minus 2 squared and factor out an x minus 2. So we're left with an x minus 2 to the first. And my x plus 1s are going to be in common, so I don't have any of those left either. Cleaning up inside my brackets, remember to multiply my negative through. So I have x plus 1 minus x plus 2. My x's here cancel, so I have 1 plus 2 gives me 3. And since it's a monomial, we like to pull that monomial to the front. So I have 3 times x minus 2 times x plus 1 squared. And there's another example of factor by grouping, which we have quantities involved. So to recap, we've done several different types of factoring. We started out with a 4-term polynomial, and we factored it by grouping it. We pulled the first 2 together and the last 2 together, factored out the GCF, and then we created 2 terms. From there, we pulled out the GCF again, and we got our x plus 20, x squared minus 5. We also looked at higher ordered exponents. So we have x to the 16th minus y to the 16th. And we were able to factor that quite extensively. And finally, we looked at being able to factor where we had quantities that were in common, which we factored essentially by grouping as well. We pulled out the GCF, and then we cleaned up what was left over if we could. And that concludes our factor by grouping and factoring larger degree polynomials.